everybody, welcome back to videos. This video is on significant digits, which are also known as significant figures. And there's three things you have to be able to do with significant figures. First of all, you have to know how to make proper measurements. And the rule when you make proper measurements is you must record all certain digits. Oh, sorry, it says you should. Certain digits are digits or things that there are markings for on your measuring device. So you must record all the certain digits, and then you estimate one more place. And you must estimate one place. We call that the uncertain digit. So anytime you make a measurement in science, you should record all the certain digits and then go one place beyond what there's a mark for. For example, if we look at these two rulers, okay, and we're looking at this, this top one with this dotted line. If you notice, this is 2, this would be 2.5. So 2.1, 2.2, 2.3, 2.4, 2.5. There are marks on this ruler for the tenths place. So those are certain. But there are no little lines in between. There are no lines for the hundredths place. So these two places are certain, and this place is our estimated or our uncertain. So if we're just looking at this measurement, we know this ruler was accurate to the tenths place, but it was estimated with respect to the hundredths place. If we take a look at this ruler, notice there's lines for 2, there's lines for 3, so we're certain it's 2, but we have to estimate this dotted line, right? We'd say, yeah, it's about exactly in between 2 and 3, or it's about in between 2 and 3, so we would estimate the tenths place. So this is our estimated place. We don't go to the hundredths this time because you're not allowed to have 2 estimated places. You're only allowed to have 1. So whenever you measure, if all scientists follow the same rules, then you can evaluate someone else's data. You know that this data is more accurate or precise than this data because this goes to the tenths hundredths place. This only goes to the tenths place. So whenever you measure, you should be doing that. In your notes, there are 3 examples on your first page. If you could do those for Monday, that'd be great. The other thing you have to be able to do, if you look on the second page of your notes, is determine the number of Sig Figs in a number. So if I give you a number, you have to tell me how many significant figures that number has. And there are basically 4 rules for doing that. First thing is that any non-zero digit is significant. So, in your notes we have a couple examples. We have 4,299. 4 isn't a 0, 2 isn't a 0, 9 isn't a 0, 9 isn't a 0. So this has, we would say, 4 Sig Figs in it. Okay? You can go ahead and do this next one on your own. The second rule is that leading zeros, okay, which come before non-zero digits, never count as significant. Okay? So for example, we can classify these zeros since they come before the 9, right? They're in front of the 9. They don't count. They're simply placeholders. So this would only have 1 Sig Fig. Again, it's very important that we do not care if it's before or after the decimal. We care if it's before or after the non-zero digits. Okay, so you can go ahead and do that example for Monday. The third rule is that captive zeros sorry about that. I think we were saying captive zeros. The main office in front of the school. First floor. Captive zeros always count. Okay? So captive zeros are zeros between non-zero digits. Okay? So here's your 8, here's your 1. Those definitely count because they aren't zeros. And then all these zeros come between them. So we would call all of those captive zeros, and they would all count. So this has 1, 2, 3, 4, 5, 6, 7 Sig Figs. You can go ahead and do this example for Monday. And the final rule when it comes to counting Sig Figs is trailing zeros. Trailing zeros count if the number has a decimal point. And for the record, a trailing zero is a zero after, not after the decimal point, but after the non-zero digits. So you always care about the zero's placement relative to the non-zero digits. Okay? So trailing zeros count if and only if the number has a written decimal point. Whoops. So I think you have the number, for some reason I skipped it. Oh, there it is. I think you have the number 1,000. Obviously the 1 counts. You would then classify these zeros. Are they before the non-zero digit, between non-zero digits, or after? These are after, so they're trailing zeros. This would only count if the number had a decimal point. And if I erase this so you can see it, no decimal point in this number. So this is only one Sig Fig, okay? You can go ahead and do that one for Monday, okay? So we measure, we count Sig Figs, and then the final thing that we do is compute with Sig Figs. And there's 2 different rules depending on what you're doing. If you are adding or subtracting, your answer must have the same places, same number of places, sorry. Oh shoot, I don't know how to get rid of that. There we go. I'm glad you found the main office. After the decimal, the same number of places after the decimal as the number in the problem with the least. Shoot. Probably should have wrote these rules out for you. It's always the least. Okay, so when you add, right, or you subtract, you want the same number of places after the decimal, okay? Which, look, after the decimal spells add, right? You want the same places after the decimal as the number in the problem with the least. So if you think of these as measurements, the idea is that your answer can't be more precise than the least precise measurement. So this guy has 2 places after the decimal. This guy has 1 after the decimal. This guy has 3 after the decimal. So once I get my answer, again, the least determines it. I need 1 place after the decimal. So I add these all up, and I get 31.123. But I need to round that so there's only 1 place after the decimal. So my answer in proper Sig Figs is 31.1. Okay, when you add or subtract, it's the same rule. When you multiply or divide, however, it's not after the decimal you care about. It's TSF, which stands for total sig figs. And the rule is your answer must have the same number of total, whoops, it's not how you spell total. Well, it's how you spell toad-all, but not total. The same number of total sig figs as the number in the question. With the least. So it's always the lowest amount, right? We're limited by the one that is the least precise. So if in your notes you've noticed you can multiply, I mean this isn't testing if you can punch these into your calculator and multiply them. They're going to have you multiply, which if you do, you get 6.384. But then you have to, they'll say express it in proper sig figs, right? Is the language that they'll use. Okay? So again, when we're multiplying, we care about total sig figs. So all of these count because they aren't zeros. This has 3 sig figs. And these both count because there's no zeros. The 1 and the 4 count as 2 significant digits, right? You count this one, you count this one. So the one that's limiting is 2, so we count 1, 2 places, and that has to be our last significant digit. So we look to the right of that. Since that's an 8, it makes this round up, and we will round this to 6.4. So 6.4 is this answer expressed to the proper number of sig figs. Okay? So 3 things that we have to do with significant figures. We have to measure with them, we have to count them, and we have to be able to compute with them. So I had asked you to do, don't forget in your notes, those couple that I pointed at. I would also like you to do this in your notes. Okay, determine how many sig figs are in each of those. And I'd like you to try these guys. These check your understandings in your notes. So have those done for Monday. Enjoy your weekend, and we'll see you Monday. Bye-bye.